Okay, this is number 43 from the textbook in chapter 2.2. As I mentioned briefly in the last video, the challenging part here is that we need to be able to come up with our profit function, or I guess in this case it's going to be our revenue function. What the problem tries to do in A and B is to build some concepts about how you're going to develop your equation when you get to part C. So this is a pretty good example of something that you could come across in the real world. Again, this would be the most simple version of the problem. It often is a little bit more complicated, but this is a good starting point. So the problem is about apartment rentals. The owner of an apartment building can rent all 50 apartments if she charges $600 per month, but she rents one fewer apartment for each $20 increase in monthly rent. Okay, so what we want to do now with part A is to construct a table that gives the revenue generated if she charges $600, $620, and $640. To do this, we're looking at revenue. Please remember that revenue is equal to price times units. In the world of apartments, we might say that revenue is equal to rent times our number of apartments. Okay, so with that being said, what we're going to do is we're going back to part A here, construct a table when the revenue is generated at 600, 620, and 640. So we can just go kind of straight down from these and kind of develop a little bit of a chart here. So when it comes to rent, the first value for rent was $600. The second value for rent was $620, and the third value that was given to us was $640. Now this is an important thing. We start with 50 apartments, but it also says for every $20 increase in monthly rent, we're going to rent one less apartment. So if we're going to start with 50 apartments, the next place, if we rent our apartments at $620, we rent one less, which would be 49 apartments. And they go from 620 to 640, we're going to rent one less, which is 48 apartments. And then to get the revenue, because we have price times unit or rent times apartment, it's just a matter of multiplication. So 600 times 50 is $30,000. In the next case, we have 620 times 49, which is 30,000. Let me just make sure I typed that in correctly. Yeah, 640 times 49, which is $30,380 in revenue. And next we could say 640 times, we have 48 apartments, $30,720. So I'm going to make some observations here and then we'll go look at part B. Well, what's important to recognize here is the distinction between what you might traditionally believe and what is the actuality in the world. You're going to notice right now at this point that as rent increases, you are increasing your revenue. And if we had another column, you would be decreasing costs because you have fewer apartments that you have to take care of. So you might start thinking to yourself, well, if I can get $30,000 or $30,720 if I charge $640, why don't we not make it $1,000? The problem with this is that at some point you're going to price yourself out of the market, and that's why we're going to have a parabola. And I remember in class the other day, some of you were a little bit shocked at this idea that we start to go down. The reason that our revenue is going to start to go down is that some people are just not going to pay $1,000 for that same apartment. So you're going to rent fewer and fewer apartments. As you rent fewer and fewer apartments, at some point your revenue is going to decrease. So go back to part B here. Does her revenue from the rental of the apartment increase or decrease as she increases from 600 to 640? Well, in this case, revenue is going to increase. It's my responsibility just to remind you that it's not always going to increase as rent continues to increase. Now let's look at part C here. Part C says write an equation that gives the revenue from the rental apartments if she makes X increases of $20 in rent. Look right here. The problem actually defines X for you. And what's going to be important for you, at least when it comes to the test, is that there's multiple ways to set up any given problem. For example, you could say instead of X being the number of $20 increases, you could say the number of apartments fewer than 50. Both of those will give you the same answer towards the end, but you do want to follow the instructions here. Right now, we know that X is the number of $20 increases. So when it comes down here to part C, as you write part C, we're going to say let X equal the number of $20 increases in rent. And that's going to be really important for us. Okay? The next part, as we're coming up with our equation, is we want to go back to this basic idea that revenue is equal to price times units, or revenue is equal to rent times apartments. So we're going to come here and say revenue is equal to rent, right, times apartments. We have that listed above, but the reason that that is important is in a moment we're going to have a binomial for rent, and later on we'll have a binomial for our number of apartments. And when we have it organized like this, we'll be able to see that rent is equal to that binomial, number of apartments is equal to that particular binomial. And the reason I want to mention that to you now is when you come down here, it says find the rent she should charge to maximize her revenue. What we're going to do when we have revenue and we find our vertex, that's going to be the maximum revenue, but we want to find this particular expression that's going to maximize our revenue. In each of these cases, for rent and apartments, we always want to start with our base unit. So our base rent was 600 and our base number of apartments was 50. So base rent, we'll start with 600. What is our base number of apartments? Well, we just said the base number of apartments was 50. And then we need to determine, are we going to add or subtract from each of those bases? In the case of rent, rent was going up. So we'll put an addition sign. In the case of the number of apartments, as X increased, or the number of $20 increases came along, we were having one less apartment every time. And so when we get down here, we're not adding apartments, we're subtracting the number of apartments, or subtracting from our total number of apartments. And then the only other thing that we have to do here is we're going to put a multiple of X in each of these spaces. Sometimes that multiple of X is going to be very simple, and sometimes that multiple of X, I guess that's redundant, will have a multiple, in this case, of 20. So let's go to rent. If X is the number of $20 increases, well, what's our total rent going to be? It's going to be 20 times whatever that X is, right? 20 times the number of $20 increases. That will give us our number for rent. But we also know, if we go back to the original problem up here, that we have one fewer apartment for each $20 increase. So for every X, for every $20 increase, how many apartments do we lose? We lose one X. And from there, we're able to develop our revenue function. Now it's a matter of foiling. From foiling, we can collect like terms, and then we will have our quadratic or our parabola. So revenue is equal to first times first. That's 60 times the 50. Well, we already did that up here, or excuse me, 600 times 50 was 30,000. So 30,000, first times first, outside minus 600x, inside plus 1,000x, right? 2 times 5 is 10, plus 2 more zeros. Here's the 10 plus 2 more zeros, so positive 1,000x. And at the end, minus, or last times last, minus 20x squared. So we foiled it. Now we can combine like terms and simplify. As we do that, let's rearrange. Revenue is equal to, let's put our square first, negative 20x squared. 1,000 minus 600 would be plus 400x. And then we still have our constant of 30,000. Okay, let's go back and make sure we're answering our question. We wrote an equation that gives the revenue for the rental apartments. We did that. Now it says find the rent she should charge to maximize her revenue. And again, this is the piece. We have to come up with our revenue function. From the revenue function, we have to find our vertex, which has an x value. And from that x value, we have to put that into our rent equation. Put that back into our rent equation. So we can find our vertex. X is equal to negative b over 2a. And it doesn't hurt to write off to the side. A is at negative 20. B is 400. And of course, our C is our 30,000. But for our problem here, X is equal to negative B, or a negative 20 is just a 20, over 2a. Oh, I did that wrong, didn't I? Negative b would be negative 400. Negative b is negative 400 over 2a, which would be negative 40. Well, 40 divided by 40, x is equal to 10. And please remember what that 10 represents. That 10 represents the number of $20 increases in rent. The question, though, is not how many $20 increases do we have. The question is, find the rent she should charge to maximize her revenue. At the same time, we were not asked to determine the maximum revenue. We're just asked to determine the rent that will give us maximum revenue. So here is our rent equation, right? There's our rent equation. So off to the side, actually, I guess I can come to a new piece of paper down here. Or actually, I'll just go down to this particular part. Rent is equal to, we just mentioned that, 600 plus 20x. 600 plus 20x. And we determined that our vertex happens when we have x is equal to 10, or 10 $20 increases. So 600 plus 20 times 10, or 600 plus 200, or $800. And then we can write a summary sentence. To maximize revenue, rent should be $800 per month per apartment. And we're done. That takes care of our apartment rental problem.